So next topic is about we should find the parameters of a binomial distribution. In last section, we learned some formulas to find the mean value, the standard deviation, when we have the probability distribution. So here we still use the formula to find the parameter mu, standard deviation, something like that. But because here we have a special distribution, we have binomial distribution, so the formula is different. I would say it's simplified formula for this special distribution. So if we want to have mu, we only need to find the product of n times p, so and so on. Here it is the notation of sigma square, and this one is actually sigma. Remember, here we are talking about the parameters. So we should use the parameters notation for the mean and the standard deviation. So we use mu, not x bar. We use sigma, not s. So if we could use the distribution to find this parameters, mu, sigma, of course, we can use this range rule to determine the value too. So remember, if a value is less than or equal to this one, mu minus 2 sigma, which means 2 standard deviation below the mean. So we will say that value is significantly low. So same rule, the range rule is just the same. But this time we use the special formula to get what is mu and what is sigma. Of course, most of the values are not significant. About 95% of the values are not significant between mu minus 2 sigma and mu plus 2 sigma. The values are not significant. So we have 3 situations. Let's check this example. So it's still the overtime example. We could use parameters, or we will say we use range rule to determine 252 is a significantly high value or not. So if we want to use a range rule, first we should use the formula to get what is mu and what is the sigma. So let's check part A. So from here, we know the special formula for binomial distribution. So mu is n times p. So remember, in this case, 460 is our n. So and 0.5. Suppose the probability of win and lose, they're equally likely, so it's 0.5. Oh, we can go back to check the question to help you understand. Overall, so this is our example. So we can, when we talk about the the coin toss, assuming that wins and loses are equally likely. So from this question, we can know P is equal to Q is equal to 0.5. That's how we get the P and the Q. So here, we want to know 252. That's our X value, right? And we know there are 460 games in total. So 460 is our N. So we go back to check this one. So N is 460, and we already know the for the coin toss, winning, losing, they're equally likely. So P and the Q, they are the same, 0.5. So we can get the mu, and similarly, we plug it into the formula to get the sigma. Remember, if we are talking about the standard deviation, don't forget the square root, okay? So this is first step. We use formula to get the value of parameter. So the second part, we need to use the range rule. So we list the two criteria, okay? So for the mu minus the two standard deviation below the mean, we just plug into the formula to get this value. Similarly, we can also list another boundary is 251. So let's check, because we are taught the last step, we need to work on if 252 is significantly high or not. So we will focus on this boundary, right? 251.4, because this is mu plus 2 sigma. Let's work on part C. Part C, we should use this one. Compare 252 to 251.4, because this one is our mu plus 2 sigma. And we realize 252 is even greater than mu plus 2 sigma. So our conclusion will be 252 is greater than 251.4. So our answer is yes. This 252 is a significantly high value. Of course, we can always use probability to determine the value is significantly high or low. Remember here, just like I said, it's not the single value's probability. It's a probability of several values, the sum of several values. So make sure you know if it's high, then it's X or more. But no matter significantly high or significantly low, it's always less than or equal to 0.05, which means always the probability should be very small. The significantly low, remember if we talk about the significantly low, still not the single X value's probability. It should be the sum of several values, X or even smaller than X. But the probability is still very small. So, if you work on this one, if you work on this part, and this is an easy way to help you memorize this one. You will find that this part is very familiar, right? So this is actually the combination part. You can treat it just like, so here it's the problem. It's not X minus, and it should be N minus X. That's a typo. Okay, it should be N minus X. So this is just the formula of our combination. This is a quick way to help you understand. We have this case, but we have a different combination. And the total formula will be the formula for the binomial distribution.